Okay, so let's talk about vertex form just a little bit. Vertex form of a quadratic equation, or quadratic function, is going to be written as f of x equals some constant a times the quantity x minus h squared plus k. Now, I like to call this the transformation form of a quadratic because, as we learned in the last chapter, these three constants are going to tell us what transformations have occurred from the graph of f of x equals x squared. So our normal parent function of x squared, of course, is just a parabola with its vertex at the origin. It opens up like that. Now, each of these constants, a, is going to tell us about a vertical stretch of this graph. So the bigger a is, the taller and skinnier our graph is. And it could also indicate a reflection over the x-axis. If a is negative, that function is going to open down instead of up. H and k, on the other hand, are going to be translations. So h is a translation in the horizontal, the x direction. And as we saw, if h here, if I have something like x minus 3, that's actually going to move my vertex in the positive direction. Or if I have something like x plus 3, that's going to move my vertex in the negative direction. And so even though we'd have x minus h, h by itself here is the actual coordinate of the vertex. So in this form, we can take a look at the vertex and say the vertex of this function is h in the x-coordinate. And the same idea, k is our vertical translation. That's going to move our vertex up and down. So if k would be plus 3, our vertex is just moving up 3. And so in that case, the y variable of our vertex is k. And so from this form, we can take a look right away at the, at the vertex of the function. We'll also take a look at finding things like the x-intercept and the y-intercept. Of course, the x-intercept is where y equals 0, and the x-intercept, or the y-intercept, sorry, is where x equals 0. And using that information, we can graph these functions pretty easily from vertex form. So let's take a look at our first example here. We've got f of x equals negative 2x plus 1 squared plus 8. And so first of all, we're going to look for is the vertex. We're going to go ahead and graph that and find, take a look at what this function looks like. So the vertex is going to come from our h term, which in this case is this 1, and the k term, which is our 8. So for us, we just have to remember, again, our transformations. This isn't anything new with quadratics, it's just one example of translations. So since we have an x plus 1 inside these parentheses, that's actually going to tell us that our whole transformation, our function transformation in the x direction, is actually 1 unit to the left in the negative x direction. So for our vertex, we have negative 1 for the x-coordinate and positive 8 for the y-coordinate. We can also tell by looking at this graph that this parabola opens downward. And so because the vertex is above the x-axis and it opens downward, we are going to have two x-intercepts in this function. So in order to find those x-intercepts now, remember, anytime you want to find an x-intercept, there's formulas out there, that's all great. X-intercepts are where y equals 0. So we're just going to rewrite this equation with a 0 in place of y. So 0 equals negative 2 times x plus 1 squared plus 8. And again, this is to find the x-intercepts. And we simply have to solve this equation for x. And we're going to do that just like we would normally. We're going to subtract 8 from both sides. We're going to have to divide by negative 2. It's going to make this number over here positive, which is great. You'll notice I picked a function here that has nice whole number roots. We're going to take the square root of both sides. Now when we do that, we have to remember there's positive and negative square roots. So the square root of 4 is 2 or negative 2. And then finally we're going to subtract 1. And I'm going to go ahead and put that out front. Negative 1 plus or minus 2 equals x. And so we have two solutions. X could either be negative 3 if we had minus 2, or it could be positive 1 if we had plus 2. And so now we have our x-intercepts here, our vertex up here, and the last thing we would want to look for is our y-intercepts. Now to find our y-intercepts, what we're going to have to do this time is plug in 0 for the x value. So we'll go ahead and take a look at that. Keep my equation here. So if I plug in 0 for the x value now, I'm going to rewrite this as y. we already have it solved for y. All we need to do is simplify our equation. So 0 plus 1 is 1, and 1 squared is 1. So we have negative 2 plus 8, which is 6. So our y-intercept is 6. So now, with all that information, we're going to go ahead and graph this function. I'm going to start by graphing the vertex, which we said based on our last paper here was negative 1, 8. So over 1 and up, way up there. So my vertex is up here. My y-intercept I'm going to graph right here at 6. Now I know this function is symmetric about the axis of symmetry, and the axis of symmetry is right there at the vertex at 1. So if this point is over here at 6, I also know there'd be a point at negative 2, 6. And then the final thing I'm going to do to graph this is to graph my x-intercepts at negative 3 and at positive 1. From there I can tell what my graph looks like. It's going to be a parabola. It's fairly steep because it's got that coefficient of 2. It opens down because that 2 is negative. It's got a maximum value here of 8 at x equals negative 1. Intercepts at negative 3 and 1. And a y-intercept at 6. And from vertex form, that's actually pretty easy to find. We get the vertex for free. Because we already have completed the square form here, solving for x is actually fairly easy. We don't need the quadratic formula to do that because this is the completing the square form. And then to find the y-intercept, we just simply have to plug in 0 for x. And we can go ahead and graph our equation from there.